Okay, so let's look at this last example called read analog voltage. Again, you can get it from the examples, basics, read analog voltage. So what it does is it reads a voltage on one of the analog pins. Those can read a voltage between 0 and 5 volts with 10-bit resolution. And it converts the analog to digital converter reading to volts and prints it out over the serial port. So if we look at the code, the setup is just initializing the serial port for 9600 baud. That's the only initialization that happens, and then everything else happens in the loop. So in the loop, again, we have this compound statement where we declare a variable, an integer named sensor value, and we assign the output of this function analog read, which is reading pin 0, that gets saved in sensor value. So this is a 10-bit A to D, so 0 to 1023, 0 to 1023. To convert that to volts, we use the scaling of 5 divided by 1023. So this is also declaring a variable named voltage, but then it gets assigned the value of sensor value times 5 divided by 1023. We put point zeros in here to make it a floating point number, so the math gets done in floating point. Otherwise, it'll get rounded off to an integer. Then it prints the voltage out to the screen, and we can read the voltage. So let's put this in our Arduino, see what happens. Looks like it's done. So I'll open the serial monitor here, find it. So we can see our voltage scrolling along here. One thing to be sure of is that the baud rate there matches the baud rate here. If you ever get gibberish looking characters on your serial port, it's probably the baud rate's not matching. Okay, so to test this out, we need to put an actual voltage in. This is just measuring the internal voltage on the chip. So analog pin 0 is here. These are the analog pins. So the first one is analog 0. You can see now it's not connected to anything. We're just getting random voltages. Again, I can measure my own voltage, and if I ground myself to that metal can, set it to 0. But generally when it's disconnected, it's a floating voltage, and you'll get random numbers. A good test is to use these voltages that are on this set of pins here. So if I ground it, we should get 0 volts. If I connect it, so we've got V in, ground, ground, 5 volts. It measures 5. We can print out here. And next to the 5 volt, there's a 3.3 volt pin, which has a really cheap regulator. So for some reason, mine is measuring out to be 3.6 volts. So I'm not sure what's lower quality, the A to D on this chip or the regulator on the board here. Probably the regulator. But anyway, it's 3.3, plus or minus 10%. It would be really good to get in here with a voltmeter and to check these values. So to check with a voltmeter, you're going to measure whatever is on the A0 pin here, and the other side is referenced to ground. So you could put a voltmeter connected to ground and A0, and it should match whatever is being printed out on the screen. Any input that's run into the inputs here, ground is the other side of the signal. Okay, well that's the whole thing.